Good evening.
Good evening, sir.
Then actually I can't remember the last topic we discussed because last week we had an exam. Then before that I think we had a session in the university. Then who can remember our last topic?
Sir, will there be a discussion on the paper, sir? Will there be a discussion on the paper, the midterm paper?
Normally we are not going to discuss. Then if you have any question you can raise, then I can explain it.
Oh, okay, sir.
I think it is not very difficult because the average marks is good. I think most of them have marks nearly around 20 out of 30. Okay, then I think we complete discussion related to binomial distribution, no? Am I correct? And we start, I think, Poisson distribution also.
So I think we did the sample selection criteria and
Yes,
methods.
that we did in the on-site class, no? Sampling distribution, we learn how to select a sample. That is the last topic we discussed in the on-site class. That part, I think we completed in that day. Then in the online class, I think, what is the topic we discuss?
So we didn't have an online class on last Saturday.
Yes, that's why I can't also remember. I think last week we had the exam. Week before, I think lecture was cancelled. Then what is the topic that we discuss?
I think it's the sample selection criteria we did that last.
Today attendance is very poor. Only 11 students. It should be nearly 30. Did we discuss this one, continuous distribution?
So I think the last thing we did was the Poisson.
Poisson. Yes, we finished that one, no?
So.
Yes. And before that, we did the binomial distribution.
Yeah.
Yes. Then, okay, then I think we'll have to start from here. Today my laptop, the camera is out of order. It doesn't work. Then okay. Then actually we had we can divide our variables into two groups: discrete variable and continuous variable. Discrete variable mean variable which we can create through the counting process. Maybe number of telephone calls, number of customers. These are we call discrete random variable. The probability related to discrete random variable can be calculated using binomial distribution and Poisson distribution. We discussed these two in the last sessions. Then in the other type of variable is we call continuous variable. Continuous variable. The variable which we can create through the measuring process. We measure the unities, we can measure, measuring process. As example, weight, height, salary, okay, income, expenditure, all these variables are continuous variable. Then to calculate probability related to continuous random variable, we can use normal distribution. We can use normal distribution. This is very important because our next topics, inferential statistics, also based on normal distribution. These are the examples for normal distribution. Sorry, not the normal, continuous random variable. Thickness of an item, time required to complete the task, temperature, height in inches. These variable we can consider as a continuous random variable. Then the probability related to continuous random variable can be calculated using normal distribution. This is we call normal distribution. Actually, when we discuss descriptive statistics, we learn the shape of the distribution. If the distribution is symmetrical, then we know that skewness is 0. Then the mean, median, mode are equal. Then it is a bell shape. Then the normal distribution mean bell shape distribution. Bell shape distribution. Let's say X we can consider as a marks for, let's say, marks for a midterm test. Marks for midterm test. It is normally distributed. It is normally distributed. Then the mean is here. Let's say mean value here. Then the distribution is around the mean. Let's say mean is out of, let's say 50 out of 100. Let's say mean is, let's say 55. Mean is 55. Okay. Then this is the minimum value. This is the maximum value. Okay. Then if it is symmetrical, median, mode, and mean are equal theoretical. Okay. Here fx mean number of students. Let's say 55, we have this number of students. Then if you take, let's say 40, we have this much of student with the marks 40. Then if you take, let's say, another value, let's say 65, we have this number of students with marks 65. Okay, then this is the distribution. Then we can see here the distribution is around the mean. Mean is here. Let's say mean increase, then what will happen to the distribution? Mean increase from here to here. Mean becomes 60. Then the distribution will shift to the right. Okay. That means we call location is determined by the mean. Location is determined by the mean. Then the spread is determined by standard deviation. Now this is the standard deviation. Okay. Standard deviation shows how each variable, each observation deviate from the mean. How each observation deviate from the mean. Okay. Now let's say for the test, if the minimum marks is, let's say, minimum marks is, let's say, 40, maximum is 80. Maximum is 80. Then the distribution is like this. The distribution is like this. Okay. Then the standard deviation is low or small value. That's why we call spread is determined by standard deviation. Theoretically, the normal distribution have value plus infinity to minus infinity. Any value it may have. These are the properties of normal distribution. Then this is a mathematical equation which we can use to calculate normal probability density function. X is our variable, then phi is a mathematical constant value, another mathematical constant value E, then the mu is the population mean. But actually we don't want to use this formula. We can calculate the probability using table. Then these things I discuss by varying the parameter mean and the standard deviation, we can see it will change. Then the changing mean shift the distribution left to right. Okay. Then with this introduction, we can move to another concept, standardized normal distribution. Any normal distribution can be transformed into standardized normal distribution. What does it mean? If the distribution is normal, okay, this is the x value, then these x values, let's say mean is here, x values, we can convert into z value. I think you learn the z value, how to convert z value. Z is equal x value of x minus population mean divided by standard deviation, z value. Now this is the formula to calculate z value. This is the formula to calculate z value. Translate from x to standardized normal by subtracting the mean of x and dividing dividing by its standard deviation. The Z distribution always has mean 0 and standard deviation 1. When you do one example, you can realize it. Then this is the formula you can use for standardized normal distribution. Okay, then this shows how we can convert X distribution into Z distribution. Now you can write down this formula, then we can do a quick exercise. Please write down this one. Z is equal X minus population mean divided by standard deviation. Now let's say we have X values. Let's say X is 20. You can write down X is 30. Let's say 40, 50, 60, 60. Then we assume standard deviation. We assume mean. Mean value is, we assume 40. We assume mean is 40. And also we assume standard deviation is 10. Standard deviation is 10. Then now you can calculate Z value. Z value. Okay. What is the Z value for 20? What is the Z value for 20? What is the formula? Z is equal X minus population standard deviation divided by standard deviation. Then standard deviation is given, population mean is given. Then what is the Z value here? Any answer? Minus 2. Minus 2. Minus 2. Then here 30 minus 1. 40? 0. 0. Then 50? 1. 1. 62. Okay. Then now you can see if I draw a distribution here, now this is the distribution X. What is the mean value? Mean is 40. No? Mean value is 40. If the mean is 40, the Z value is 0. Now this is the distribution of X. When you convert X distribution into Z, mean 40 becomes 0. Mean 40 becomes 0. The value less than mean, let's say 30. What is the Z value? Z value minus 1. If the values are below the mean value, Z values are negative. Okay. Then Z value, okay. Then here let's say 50. 50. Z value is 1. Now you can realize for the mean Z is 0. Okay. If the X value is less than less than mean, the Z value is minus. If it is greater than, the Z value is plus. Then actually yesterday, one of the student who did A-level last time, they got the results, I think last week. Then they came to visit me, get some advice. Their problem is she has a Z value minus Z value. Then they think that it is something wrong. They are asking why my Z score is minus. Okay, why Z score is minus? What is the reason? She has Z score minus 0.0 something like this. Then they think that it was a mistake. They are asking why their Z value is minus. What is the reason? How to calculate Z value in A level? Yes, how to calculate? One say that we already this one. Who say that?
Yes, sir, we covered that one because May,
That's why I
Yeah.
asked from you, because
15 July and 5th August.
As we did not do the session in last week, then I can't remember actually what is the topic. That's why I asked. Then I think this one also we complete all the part, no?
The empirical rule was we have done it 15th August. So
Then yes. Then we will have to start, I think, a new topic. Okay, then just we can our discussion we can conclude and we can move to the new part. Okay. Then actually my question is now why some student for the A-level results, why they get minus Z score? What is the reason? Yes. What is the reason? Any answer? Why they have minus Z score? Yes, one say mean is higher. Yes, mean is higher, then why we get the minus value? Yes. Then the Z is minus when the X value is, now this is the mean value. If the X value is less than mean, Z is minus. Z is minus. Then they get the minus Z value because maybe all three subjects, the marks obtained by that student is less than mean value. Then Z value become minus. If you can obtain marks above average, then you can get a higher Z value and plus and higher Z value. Okay. That is the reason. Okay, then so okay, then I think I give some brief introduction to normal distribution. I think we have to start new topic, I think sampling distribution. Okay, then we will move to new topic, sampling distribution. Then here we are going to discuss the concept of sampling distribution, then the compute probability related to sample mean and sample proportion, then the importance of central limit theorem and the different sampling method. That part we discussed, actually different sampling method we discussed. Then these 4 topics we have to discuss. Whatever. Okay. Then we will move to the concept of sampling distribution, because this is very important concept. The inferential statistical techniques are based on sampling distribution. The concept of sampling distribution we can discuss with a very simple example. Then later we will move to this definition. Before that, we can have a quick discussion about sampling distribution with this simple example. Now we assume we have a population. The population size is 4. In the population, we have person A, B, C, D. 4 individuals. Then we are going to do a study about age. We are going to do a study about age. Then we can say X is random variable age of the individual. Then their age are 18, 20, 22, and 24. Then based on these informations, we can construct probability. We can construct population distribution. Now we have one person with age 18. Then out of 4 people, there are 4 people. Out of 4, only one age is 80. And out of 4, only one is age 20. Again, out of 4, only one is 22. Out of 4, only 1 is 24. Then this is the probability we are having one person with age 80. And also this is the probability we are having one person with age 20, 22, 24. This is the population distribution. This is the population distribution. Then for the population, we can calculate population mean. Population mean is 21. Then the standard deviation we can calculate, it is 2.236 is the standard deviation. I think you got the point. This shows the population mean, standard deviation, and the distribution of population. Then in the next stage, what we can do is we can select samples. The sample size is 2. Okay. Then we have used a sampling method with replacement to select a sample from this population. There are 4 individuals in the population. Then our sample size is 2. Then if you select samples with replacement, you can select 16 possible samples. Let's say this is the person A, B, C, D. A, B, C, D. Okay. Then then this is, we can consider one sample. In our first sample, we have person A and A because we select the sample with replacement. In the second sample, we have A and B. Third one, A and C. Fourth one, A and D. Like this, we can have 16 different samples. Is it clear? From the population, we can select 16 different samples. Okay. Then, in the next stage, we can calculate mean for each sample. Mean for each sample. Then the first sample, mean is 18. The second sample, mean is 19. Third one, 20, 21. 19, 20, 21, 22. Now these are, we call means, sample means. Sample means. Okay. Then, now you can see sample means the values are 18. Sample mean values are 18. 19. 20. 21. 22. 23. And 24. Then how many sample means altogether? 16 sample mean. Then out of 16, Px bar. Out of 16, how many samples with mean 18? How many samples? Only one sample. Then how many samples with mean 19? How many? 2 samples. How many samples with mean 20? 3 samples. How many samples with mean 21? 4 samples. Like this, you can fill this table. Then it shows the probability. That means if you select a sample from this population, what is the probability that you have a sample with sample mean, let's say 23, sample mean 23, sample mean 23. What is the probability? Any answer? Now, if you select a sample from this population, what is the probability that you have a sample with sample mean 23? Any answer?
2.
Yes, there are 2 samples with sample mean 23. I ask the probability. There are 16 possible outcomes. No? Out of 16, you can see there are 2 samples with mean 23. Then if you calculate probability, you can have a sample with mean 23. The probability is 1/8. Did you got the point? What is the probability that you have a sample with sample mean 21? Sample mean 21. Yes.
4 out of 6.
Yes, there are 4 samples. Then out of 16, 4 we have 21. Then if you select a sample, there is a probability, yes, 1/4, or you can say 25% probability. You can have a sample with sample mean 21. Okay, 21. Then now if you plot the probabilities, then you can have a sampling distribution of mean. Then you can realize how we get this one. With the sample mean 18, what is the probability? Only one sample. That means 1/16. 19, how many samples? 2 samples. Probability is 2/16. Okay. Then this is we call sampling distribution of mean. Sampling distribution of mean. Now it is a normal distribution. Then I explain how to draw sampling distribution of mean. Then now we can move to the definition of sampling distribution. You can see sampling distribution is a distribution of all of the possible value of sample statistics for a given size sample selected from a population. What do you mean by sample statistics? It may be mean value, or proportion, sample proportion are the statistics. Given value, given sample size. In our example, sample size is 2. Then all possible value. In our example, we had the population 4. Then the possible all samples are 16. Then if you calculate sample mean for all these 16, then you can construct sampling distribution of mean. I think you got the point. Is it clear now? What is the meaning of sampling distribution? If you have any doubt up to this point, you can raise, because the foundation of our next series of discussion is based on sampling distribution. Then this should be very clear to you. Any clarification?
So generally it's for mean.
Yes, we can calculate actually sampling distribution for mean, this one. And also we can calculate it for sample proportion. Let's say if you consider MFE group, now in this class we have 25 students including me. Then let's say from this 25 we can select sample with sample size 5. Okay. Then for this sample, let's say we can select person A, B, C, D, like 5 people. Then from this sample, we can calculate, let's say, proportion of students who are using, let's say, prepaid connection. Okay, prepaid connection, proportion. Let's say the proportion of students who are using prepaid 20%. Okay, this is from one sample. Then from this population, you can select another sample. No, you can select many samples. Then you can calculate sample proportion. Then based on these sample proportions, also you can construct sampling distribution of proportion. We will do this one also later. I think this is clear to you. Then we have another concept. Now, see what is this one? Summary measures of this sampling distribution. Sampling distribution means the distribution of X bar. We have X bar values 18 to 24. There are 16 X bar values. Okay. Mean values. Then we can calculate mean of the mean. We can calculate mean of the mean. The 21 is mean of the mean. Means are 18, 19, 19 up to 24. Then you divide this. This shows mean of the mean. Then we can calculate standard deviation related to mean. It shows how each mean deviate from mean of the mean. Okay. This should be very clear to you. This is not mean. This is the mean of the mean. If you write down like this, if you have X here, then mean of the X. Now mean of the mean. Standard deviation of the mean. Okay. Then standard deviation is 1.58, mean is 21. Then now we can have a comparison between population and sample mean distribution. Now you can see the similarities and dissimilarities. Then the mean is 21, sample mean. In the mean of the mean also 21. Is it clear? Population mean 21. In the population, we have 4 individuals. When you calculate the mean, it's become 21. Okay. Then what is the mean of the mean? We had 16 samples, then the 16 means, then when you calculate the mean of the mean, it is 21. Then the population standard deviation, this value, then the standard deviation related to mean is this one. Then there is a relationship. The relationship is, you can check, this is equal population standard deviation divided by square root of n. What is the population standard deviation? 2.236. Then the sample size 2. If we divide 2.236 by square root of 2, it should be equal to 1.58. Then now you can see the relationship between population and sample distribution mean. The population may be not normal, but if you select a sample, the sample distribution may be normal distribution. Then the mean, population mean is equal to mean of the mean. Then standard, this is we call standard error of the mean, or we can say standard deviation of the mean. It is equal population standard deviation divided by square root of a. Okay. It is we call standard error of the mean. Different sample of the same size from the same population will yield different sample mean. We observe that sample mean minimum is 18, maximum is 24. There are many values, 18 to 24. Mean is 21. Standard error of the mean. It shows how each mean value deviate from mean of the mean. Then you can see the standard error of the mean decrease as the sample size increase. If the sample size increase, the standard error of the mean decrease. Okay. Okay, give me 1 minute. Okay, then
Excuse me, sir. In the previous slide, standard deviation of x bar was derived by dividing by 16.
this one,
The previous one.
yes, 16. Because
Standard, not 2.
this one you are asking.
Yeah.
Yes, then here, this is, we have actually the how now x bar values, how many x bar values we have? 16. That's why we divide here 16. These are not x value, x bar. Then this is not the standard deviation of x, standard deviation of x bar. That's why we divide by 16, because we have 16 samples. Here,
So if we are using standard deviation of the sample, then only we divide by root of n, which is 2.
yes. Now actually there
In
are
slide
two. Yes,
10.
there are two methods to calculate standard error of the mean. Okay. The one is this one. The second one is population standard deviation divided by square root of n. This formula is something different. What is this one? Actually, this is x bar value is the 80. Then what is the 21? 21 is the mean of the mean. Just say mean. The 19 is x bar value. 21 is mean of the mean. Then you take this shows how each sample mean deviate from mean of the mean. One sample 1 is 18, mean is 18, but the average sample mean is 21. Now, is it okay?
Yes, sir. Thanks.
Okay, then this again summarize the things we discussed. Mean of the mean is equal to population mean. Standard error is equal to standard deviation of the population divided by square root of n. Okay, then we will move to again very important concept. Then Z value. At the beginning also I explained the Z value. In that point, we calculate Z value for value of x. Now we have a value of x. Then here Px, probability. Then the distribution is like this. Then this is the mean value. Then this one we can convert to Z. Then the mean of the Z is 0. Then the Z distribution we had like this. How to convert this x into Z? Z is equal x minus population mean divided by standard deviation. Using this formula, we convert these x value into Z. Okay. Now we have another distribution. It is not x. it is the distribution of X bar. Now, you have to try to understand the difference. Now, this is X bar. This is X. Then the X bar distribution is like this. Then this is the, now here this is the mean of the X. Okay, mean of the X. You can write down it like X bar. Now, what is this value? This is the mean of the mean. Mean distribution. These are the mean value. Now, this is the mean of the mean. That means this is the mean. You can use this formula. Then this one, we can say is the mean of the mean. Mean of the mean. Okay. Then now we can convert this distribution also into Z. How to convert? Use this formula. Okay. Now Z is equal X bar minus mean of the mean divided by standard error of the mean. Now this one, we can use the another method, standard deviation divided by square root of n X bar minus population mean. Then this is the Z distribution. Is it clear? What's the difference between this formula and this one? Now both Z, but this one is related to X bar. This one is related to X. Then this is the distribution of X. Then this is the distribution of X bar. Then if the sample size is large, the distribution of X bar is like in red color. If the small sample size, the standard deviation is high, then it shows like in a blue color line. Okay, then this part I will explain later. Then we will move to another concept called central limit theorem. It's very simple. The central limit theorem says even if the population is not normal, sample mean from the population will be approximately normal as long as the sample size is large enough. That means now we learn in our example, the population is not normal. The population is uniform distribution. Population size is 4. We select samples with sample size 2. then we calculate sample mean of the mean and the standard error. Then we realize that sampling distribution become normal. It's the one conclusion of central limit theorem. It says, even if the population is not normal, sample mean from the population will be approximately normal as long as the sample size is large enough. These are the properties as I explained. Mean of the mean is equal to population mean. Then the standard error is equal to standard deviation divided by square root of n. As sample size get large enough, then the sampling distribution become normal. Now, blue color one shows the small sample. Then the red color one shows the sampling distribution of mean if you select a large sample. Then same thing here, you can see population distribution is not normal, but for the large sample, sampling distribution is normal. Then we can say large sample. The large sample mean, what is the large? Then we can say large mean it should be greater than 30. Greater than 30. If the population is symmetric distribution, then the sample may be 15, greater than 15, also acceptable. Okay, then we will move to one example. Okay. Then suppose the population has mean 8. Population has mean 8. Standard deviation is 3. Sample size is 36. What is the probability that sample mean is 7.8 to 8.2? Now let's say if I further explain this concept. Let's say in our class, assume that now we are having 25, let's assume we have 36 students. Our sample is 36. Let's say this is the MFE student selected from 2023 and 2022. Okay, this is the sample. Then from the population mean all MFE students, we can calculate sample mean. Let's say this is the number of telephone calls they are receiving per day. Okay, number of telephone calls. If you collect data from population, it shows that population mean is 8, sample mean is 3. Sorry, standard deviation is 3. Our population is all MFP students. There may be nearly 200 students. Okay, 200 students. Then when you calculate the population mean, it is 8. 8 mean, let's say, number of calls they are receiving per day. On average, it is 8. Standard deviation is 3. Okay. Now, what we have done is, now we have select a sample. Sample size is 36. Then they ask, what is the probability that the sample mean is between 7.8 to 8.2? What is the probability that sample mean is between 7.8 to 8.2. How to do this exercise? Okay, how to do this one? Is it clear, the question? Now our population is, let's say, 200. Population mean is 8. Population standard deviation is 3. Now you have select a sample from this 200. The sample size is 36. Then the sample mean, we don't know value. It may be any value. Then we want to know if the population mean is 8 and standard deviation is 3, what is the probability that sample have sample mean 7.8 to 8.2? This is the way to calculate it. Even if the population is not normal distributed, the central limit theorem can be used if the sample size is 30. Now here sample size is 30. So sampling distribution of X bar is approximately normal. Then the mean of the mean is equal to 8. Standard deviation is equal to 0.5. Because population standard deviation divided by square root of 8. Then now you can use Z distribution. You can convert distribution of X bar into Z. Mean value is 8. Then the X bar value 7.8, 8.2. Then what is the Z value related to 7.8? It is minus 0.4. What is the Z value related to 8.2? It is 0.4. It is 0.4. Okay. It is 0.4. Then the probability of we are having sample with mean between 7.8 to 8.2 is equal to this pink color area. Then from the Z table, you can get or you can calculate probability related to this area. How to calculate it? You have to read the Z table. I think I have shared the Z table with you. Then check whether you can get the answer here. This is the Z table. Please check whether you can calculate probability related to this area. This is minus 0.4, This is plus 0.4. Today my computer is out of order. The mouse doesn't work and the camera doesn't work. Then I will have to use my fingers to draw all these things. Then here minus 0.4, here plus 0.4. Then what is the probability in this area? Actually, I explained how to read the table when we are doing normal distribution. Then I will give maybe 2-3 minutes. Please check whether you can get the same answer. And I can share the, I think, the slide with you in the chat box. I can share. Okay, then the slides are in chat box. I'll give 2-3 minutes, then try to get answer. Okay, then how to get the answer? Who can explain? Then you want to find the probability in this area. Then here value is 0.4. Then here value is minus 0.4. Then I put here A. This area we can say A. This area B. This is this part C. Okay. Then we want to find probability related to area B. How to find? Any suggestion? We don't have minus Z value here, only plus. You can read 0.4. 0.40. That means to read the Z table, you should have actually two decimal places. 4, 0. 0.40. 0.40. 0.40 means 0.4, 0 from here. Then the answer is this. Then answer is 0.654. Then this is equal, whether this is equal A, B, or C. Now when you read the table, it gives the probability related to given Z value, left to the given Z value. Then this value is equal to probability area A plus B. A plus B. Okay. Now you want to find B. How to find B? This is equal to A plus B. Now you want to remove A. How to remove A? Any suggestion? Hello? How to find area B? You have to remove the A. What is the relationship between, you can see, A and C? A and C. This is a symmetrical curve, then A equal to C. Area A should be equal to area C. Then if you take A plus B plus C, this is equal to 1. A plus B plus C is equal to 1. Then you know A plus B is 0.6554. Then what is the C now? Yes, what is the value of C? How to find C? C is equal 1 minus 0.654. Then you can find the value for C. Then that value you can subtract from 0.654, 0.6554. Okay, that is the answer. Yes, what is the answer? Can you send the answer into chat box? Did you got the point? One minus 0.6554. Answer is 0.3446. Then the area B is equal 0.6554 minus 0.3446. Answer is 0.3108. 0.3108 area. Is it clear? Hello. I think you have to actively engage to the class. Otherwise, actually, I don't know whether you are doing something else. Then no response. Yes. Did you got the point? Is it clear?
Yes, sir.
Okay. Then here 0.3018 mean the probability. Okay. What is our question? See, if you select a sample with sample size 36 from a population with population mean 8 and standard deviation 3, the probability you have a sample mean between 7.8 to 8.2 is 0.3108. I hope you got the point. This is the thing that you should know about sampling distribution of mean. In the next session, we can. I think that also we can finish. I think now it's very small. Then the next topic is population proportion. For the population proportion also, we can calculate sample proportion, mean sampling distribution of proportion. Then in the previous example, we had the population mean, and from the population, we select different samples and we calculate sample mean. Then similarly, we can now calculate sample proportion. Okay. Sample proportion is as I explained earlier, let's say proportion of students who have postpaid mobile connection. Sample proportion is always between 0 to 1. Okay, 0 to 1. Then the sampling distribution of proportion, also similar to sampling distribution of mean. It also normally distributed with standard deviation, and a mean of the sample proportion is equal to population proportion. If the sample size is greater than 5, here n is sample size, 5 is the population proportion. If these two conditions are satisfied, then we can say sampling distribution is normal distribution. Then sampling distribution also we can convert into Z distribution using this formula. Okay. Now this is sample proportion, population proportion, sample standard deviation. Then let's see this example. If the true population proportion of voters who support proposition A is 0.4, that means the 40%. This is the population proportion. What is the probability that sample size 200 yield a sample proportion between 0.4 to 0.45? Let's say as example, you have a large sample, let's say population, large population, let's say population size is 2000. Then in this population, we can see 40% are using prepaid connection. In the population, 40% are use prepaid connection. Then the population proportion is 0.4. Now from this population, you have select a sample. Sample size is 200. Then in this sample, what is the proportion of individual who are using prepaid? Okay. We have to calculate. Then before that, we can calculate the probability. Let's say, if you select a sample with 200 from this population, what is the probability that you have a sample proportion between 0.4 to 0.45? Okay. Then you can use the Z distribution. Okay. First, you have to calculate the standard deviation using this formula. Then the standard deviation is this value. Then use this formula. Please write down this formula, then I think it is easy to use. Z is equal P minus population proportion divided by standard deviation. Then you can see here, this is the P sample proportion, this is the population proportion, then this is the standard deviation from here. Then the Z value is 0 to 1.44. If I go here, Z table, Z1, I think you can understand. This is the sample proportion. Okay. Mean value is 0.4. Then you can convert this into Z. When you convert Z, this value 0. Then value related to 0.45 is 1.44. Now from the table, you have to find probability related to this area. This is similar to the previous example. You can read Z table 1.44. Then you have probability related to A, B, and C. Then you can find the probability related to C. And again, that value you have to subtract from A and B. Then you can find the value. Then the answer is 0.4251. I hope you got the point. Okay, then this is the end of discussion related to sampling distribution. The sample selections actually we discussed in the on-site session. Then the next week we will discuss confidence interval estimation. We have actually a few more topics to be discussed. Confidence interval, then the hypothesis testing. Under hypothesis testing, 1 sample, 2 sample, and ANOVA. There are nearly 4 topics we have to discuss. Okay, then this is the end of today's discussion. I hope you learned something from today's session. Then if you have any clarification, you can raise. Otherwise, I am going to wind up the session.
Sir,
Yes.
this data set for the assignment, does everyone in the group have to upload to LMS?
Yes, it is better. Then for the recording purpose, the same data set in your group, let's say there are 5 members, then all 5 members can upload same table and the same document into LMS. Now I think LMS link is available. Some of them have emailed to me, but I think better to submit it into LMS. Early October, actually now we are in I think 20th week, but a few sessions were cancelled. I think we can have the exam, I think September. Now we have 3 more weeks. I think, yes, most probably. I will check with the other lecturers. Maybe second week of October, we can have, I think now we are in the, we have 3 more weeks, no? Then my sections I can actually complete within 4 sessions. That means the if you can have additional session, maybe I can finish my topic in the September. Then I will check with other lecturers, and next week I will announce exact date for final exam and the exam registration date. And for the before exam registration, I think some of them have pay only a first installment. I think they will have to pay the second installment before apply for the semester 1 final exam. All detail I will circulate early next week. Okay. The assignments. It's okay, I think. It doesn't matter, yes. We can have, I think, exam as scheduled in the October, maybe not the first week, maybe second week we can have. No. Normally we can have actually last time what the practice was 2 subjects. In the first day we can have 2 subjects. That means exam we are having Saturday and Sunday both. Then the first Saturday we can have 2 subjects. Then the Sunday 1 subject. Again in the next week, Saturday 2 subject and Sunday 1 subject. There are 2 weeks, 2 weekends for the final exam. Okay, then shall I wind up?